When we are talking about fluids, we can think of some pipes through which the fluid is flowing. These pipes can go up and down, stretch, widen. If the fluid is incompressible and is in the laminar regime, we know that the energy is going to be conserved. Consider an incompressible fluid with no turbulence flowing through some pipes. We know that if the pipes narrow down, then the velocity of the fluid and therefore its kinetic energy increases. We also know that if the pipes go up, then its potential energy increases. There has to be a balance between the changes in kinetic and potential energy and the work done to move the fluid around. The way we push the fluid is through pressure difference. A difference in pressure makes the fluid move one way or another. Imagine we have this simple pipe that goes up and it narrows down. There's a pressure down here that pushes the fluid to go up. The pressure is given by the force applied over the surface area. Up here the volume remains, although the shape changes. The pressure up here is the force acting over the surface area. The work done on a certain volume of the fluid to push it up is the force times the differential of displacement, F1 dx1, minus, as we are interested in the difference, F2 dx2. This is the pressure difference times the differential of volume. So the work done is due to the difference in pressure. The change in kinetic energy of the fluid is 1/2 of the mass, which is rho times differential of volume times velocity squared. So the change in kinetic energy is 1/2 of rho dV V2 squared minus V1 squared. For the change in potential energy, we have that du is mgy2 minus mgy1. Because of energy conservation, we then have that delta P is equal to 1/2 of rho delta of V squared plus rho G delta of Y. We can move everything with the subindex 1 to the left-hand side and everything with the subindex 2 to the right-hand side. This is Bernoulli's equation, valid for an incompressible fluid and frictionless fluid. The combination of the pressure plus the kinetic energy plus the potential energy is a constant through the pipeline. Let's assume we have a static fluid such as water in a pool. Then the kinetic term is 0, and if we consider the origin of height as at y1, then we have a familiar expression, the one that tells us that pressure increases linearly with depth. From this expression, if you consider a horizontal pipe, the potential energy term cancels. We then see that the higher the velocity, the lower the pressure. So if you create a channel of fast-moving fluid, you are creating a low-pressure channel. The pressure difference can push objects to it. Look at this hair dryer and its ping-pong ball. If the dryer is pointing up, you might think that the ball is levitating because of the air pushing upwards. But what happens if the dryer is tilted? The ball still doesn't fall. This is because of the pressure difference. The pressure from the surrounding pushes the ball to the low-pressure channel created by the dryer, which can easily be explained by Bernoulli's equation. May science be with you.